Hello, students. Once again, we are back with a new topic in physics. In our previous classes, we had studied about motion in detail. We had studied a lot of topics that help us to understand motion and its different types, equations of motion. We had solved a couple of numericals based upon the formulas that we had studied in that lesson. But one major question that was left to be answered: what produces motion? Now, this very important question was yet to be answered. Even though we studied about the different types of motion, still, this very question, that what is the basic cause, what agency is responsible for producing motion, that is yet to be answered, and that's exactly what we are going to discuss in our next chapter. What produces motion? Now just look into the picture. You can see two people putting some effort in order to move an object. Now at this point I would like to ask you one question. Is the effort applied by both the person same? Is it similar or is there any difference? There is a difference. What is the difference? In the first picture, the effort applied by the person is referred to as a push, while in the second case, the effort is said to be a pull. So, whenever we are applying an effort on any object, it could be a push or a pull. Some more examples regarding push and pull, like pushing a switch, pushing a ball with the help of a hockey stick, pulling a box, or pulling the rope in order to hit an arrow to the target. So now one question: what basically is this effort that I am talking about? What basically is a push or a pull? That is nothing but what we refer to as force, and that is exactly the reason for any type of motion. Now if you remember the question that was asked on the very first page of this presentation, what produces motion? So force is responsible for producing motion, or rather I should say force is the external agency that tries to produce motion in objects. So what are forces? A force is a push or pull upon an object resulting from the object's interaction with another object. Like again you can see in the picture a push or a pull. So obviously two objects are interacting with each other. There is a kind of interaction between the two objects, and that interaction is what is usually referred to as a force. Now all through your junior classes you have studied the elementary definition of force, that it is simply a push or a pull. A push or pull is called a force, but now we can slightly modify this definition and we can say that it is a push or pull upon an object resulting from the object's interaction with another objects. Whenever there is an interaction between two objects, there is a force upon each of the objects. Now this is a very important point. Whenever there is an interaction between two objects, there is a force upon each of the objects. So this is what is the basic definition of force. Now you can see in the picture that there are different situations showing how force may be acting. So you can see pushing, pulling, squeezing, some common activities that we come across in our day-to-day life, and each one of these are some kind of a force. Types of forces. Now, this is not exactly different types of forces, rather I should say that I have shown you the examples of different types of forces, because based upon the knowledge that we gather with the help of these examples, we can classify forces into different categories. Now this is not a new topic for you, because in class 8 you have already studied about the different types of force, but still with the help of these examples I would like to ask you that what are the different types of forces that you can understand with the help of these examples. Now you can see in the picture friction force, gravity force, force applied in order to move that trolley, so it's an applied force. Then there is a drag force. You can see the direction in which the drag force is acting. With the help of arrow in every picture, actually the direction of force has been shown. There is a spring force, a magnetic force, tension force, and lastly buoyant force. Now about buoyant forces we would be studying in a bit more detail in the coming lessons, but for the time being just we'll restrict with the examples. So friction, gravity, applied force, drag force, spring force, magnetic force, tension force, and finally buoyant force. These are the different types of forces, or rather the examples of different types of forces. Now can you figure out any difference between the different types of forces that have been shown in this picture? So actually the basic difference is the manner of interaction. Now I will once again show you the picture of the different types of forces. You can easily understand that in some of these examples there is a direct interaction between the two objects based upon direct physical contact. Like suppose when we are pushing or pulling an object, we are actually touching that object. There is a direct physical contact between us and that object. Suppose we are asked to push a table, or suppose the example that you can see, the man pushing the trolley. So obviously, unless he is having a direct contact with the trolley, how he is going to push the trolley? There is going to be a direct physical contact between the hands of that man and that trolley. So one type of force is placed in this category. While on the other hand, just consider the example of gravity force, or say the magnetic force. You can see between the magnet and those iron nails, there is no direct physical contact. There is a space between the two objects, between the magnet and the iron nail, but still a force is existing. Still some interaction is existing. Still some interaction is going on. So that is what helps us to place these type of forces in another category. So based upon whether there is a direct physical contact between the two interacting objects or not, we can classify forces as contact forces and non-contact forces. Now this you have studied in the syllabus of class 8. Contact forces were interactions between objects that touch. There is a direct physical contact. So applied force, spring force, a drag force, frictional force, and the normal force. While non-contact forces attract or repel even from a distance. Actually, these forces are called action at a distance force. This means the two objects that are interacting with each others are separated through some distance. So you can consider the example of magnet that can attract iron objects even from certain distance, or say electric force, like for instance you can have a plastic scale that you can rub in your dry hair, and then if you bring that plastic scale near some small bits of paper, even from some distance you will find that those bits of paper are getting attracted to that plastic scale. And last but not the least, gravity. Gravity, which is responsible for holding each one of us on the surface of this earth. So, gravitational force, like even if we jump from the surface, still we fall back on the surface because Earth's gravity pulls us back. So, even though there is no contact between us and the ground when we have jumped, still we fall back just because the Earth's gravity is strong enough to pull us back. So, gravitational force also falls in the category of non contact forces. So, we are having two types of forces, contact forces and non contact forces. Now, after that, we have studied about the types of forces. Now, we will study about the possible effects of forces. Now, I will like to tell you one thing. There is something that you should remember. Force always tends to bring about a change, or rather, I should say, it always tries to bring about a change. Now, there is no such compulsion that whenever we are applying some force on an object, there should always be some kind of a change. Force is always trying to bring about a change. It totally depends upon the magnitude of effort, magnitude of force applied on the object as well as on the mass of that object. Like suppose if you are trying to pull a heavy box, as you can see in the picture, it totally depends on the mass of that box, whether we have applied a force enough, good enough so that we are able to push it. So unless we are applied a huge amount of force, huge amount of effort, then we will not be able to make that box move from its position. So we are simply trying. So that's why you can see that it is written, it can change the state of object or motion of the body. Like sometimes I find students writing down, when they're asked to write down the possible effects of force, they write down force brings the change in state. You should write down force can change the state of rest, or force tries to change the state of rest, because even there are situations that after applying force there is no change as such. Like if I ask you to push a wall, will you be able to move it from its place? Obviously not, because the wall has got a huge mass. So how hard you try, manually it is just not possible to move that wall from its position. So, force can change the state of rest or motion of the body. We sometimes give this effect as, or write this effect as, force can change the state of the body simply. Now, state includes both the state of rest and state of motion. Like force changes the state of motion of a tire, makes it to move faster. Now, it's a common game that you find small children playing. They like rolling a tire with the help of a stick. Or you can see in the next picture, a box at rest moves due to force. Like anybody can give me any example where an applied force is trying to stop a moving body. Like in these two examples, you can see that the force is trying to make the body move. But can you give me any example where the force is trying to stop a moving body? Very simple. All of you may be knowing how to ride a bicycle. So, whenever you are trying to stop a bicycle, what basically you do? You apply brakes. So, by applying the brakes, you are able to stop the motion of the bicycle. So, applying brakes is also a force, and this force is actually trying to change the state of motion of the body. That is, it is bringing the object to rest, or rather I should say it is trying to bring the object into the state of rest. Another effect of force is it can change the size or shape of the body. Like for example, force applied by hands on the dough changes its shape. This is one example related to our day-to-day life. All of us observe this in the kitchen every day. Whenever the chapatis are made, so with the help of the hands, the flour is kneaded into a dough, and with the help of hands, the dough is changed into small spherical balls, and ultimately, with the help of that, a kneading pin with the help of that rolling pins rather, we are changing the shape of that spherical ball into a disc. So many times force is being applied to change the shape. Suppose in the morning, the first thing that we do is to brush our teeth. So obviously by pressing the toothpaste tube, we are changing the shape of the toothpaste tube, we are deforming it. Another example, force changes the size of a rubber band. By pulling it, we are actually changing its length. Change in dimension is actually referred to as change in size. So length, height, thickness, this is referred to as size. And when you are changing the way it looks, like for example the potter, when a potter applies force on with his hands on the clay, kneaded clay, then he can change it into so many beautiful shapes. He can make so many beautiful pots or sculptures. So that is one example where by the application of force with the help of hands you can change the shape of a body. So what are the effects of force? It can change the state of rest or motion of the body, and secondly it can change the size or shape of the body. Some more examples. A man uses a force to move a stationary lawn mower. A cyclist uses a bigger force to paddle his bicycle and increase its speed. Now, this is something that you all might be doing every day. Most of you might be using a bicycle to come from your home to school. And obviously, in the morning, you might be a bit more of a hurry. So sometimes you always paddle faster to reach to your destination in a less time. So obviously you should not do it. You should take some time and then reach to your destination. But still, sometimes we apply force on a bigger force on a paddle so that it increases its speed. Similarly, we can apply force on a bicycle in order to stop it by applying the brakes. Second, a footballer uses a force to change the direction or motion of a ball. Now you can also cite the example of a hockey match where so many players are changing the direction of the ball with the help of their hockey sticks. A baker uses a force on his dough to shape it into a curry puff. Now, this was one example given in the previous page also, where you found that with the help of your hands you were changing the shape of the dough while making roti, chapati. A similar example is given where a baker is using a force on his dough to shape it into a curry puff. So these are some common day-to-day life examples to understand the effects of a force. Now I would like you to think of many such examples related to day-to-day life, your common life, where you can observe different effects of forces. And you should note it down in your copy. Now something important. Balanced forces. Now before we understand what are balanced forces, I would like to ask you one question. What is the meaning of balance? Have you seen a balance? I hope all of you have seen a balance. All of you might have visited a grocery store or a vegetable seller's store. You might have seen a balance. A balance is used to weigh the objects. You might have seen some weights placed on one side and the commodity, the object that you want to purchase is being placed on the other side, and then with the help of a pointer that lies in between, the shopkeeper is trying to bring a balance position, and then when the weights, the masses on both the sides are similar, then exactly you get that commodity. So balanced forces also refers to a similar situation where forces become equal. Like in the case of a balance, a common balance that you observe in a grocery store, the masses of the objects on the both sides of the pans become equal. Similarly, in this situation of balanced forces, forces acting on one object become equal. Like you can see in the picture, two people are trying to push a box, but what is the difference in this case? The difference in effort is the direction. As you can see, one direction is towards right while the other direction is towards left. Now, if the forces applied by both the people are equal forces, suppose each one of them apply a force equal to F, then obviously equal forces acting on one object will cancel out, and ultimately there will be no change in the object's motion. There will be no change in the object's motion. So net force is equal to 0 and hence there will be no movement. Now one question might arise in your mind, that how can we understand that net force is equal to 0? Like again I have marked that the applied force in both the sides, since they are equal, so let the force applied by every person is equal to F. Now if you remember, in the previous lesson we have studied about vector quantities. Do you remember that? What are vector quantities? Vector quantities are those physical quantities that have got both magnitude and direction. So force is a vector quantity. So obviously it has got both magnitude and direction. So if one direction is considered to be positive, then the other direction should be considered as negative. So suppose I consider that the direction towards right is positive. So obviously the direction towards left will be negative. So now if I are asked to find out the total force, on the box. So obviously in order to find out the total, we have to add the values of forces. So total force will be F plus F, but we have to consider the direction also. So obviously one force is positive while the other force is negative. So now the total force becomes plus F plus minus F, and that turns out to be how much? 0. So that is what is written here, that net force is equal to 0, and so if no force is acting on the object, so there should be no movement. So in case of balanced force, an object standing still will not move, an object moving will not stop. Now again there is a misconception among students that if no force is acting on the object, how can an object move? But suppose you consider the example of an object which was already in the state of motion. Once you have applied some force and then made it move, and then that force has been removed, unless some other force is applied, the object will continue moving. So for balanced forces, if an object was at rest, then it will continue at rest, it will not come into motion. And if the forces are balanced, again if the object was moving, it will continue moving, it will not come to rest unless some force is applied again. Understood? So now we will study about unbalanced forces. Now one more example to show how the forces on the book are balanced. You can see the forces applied on the physics book, which is kept on the surface of a table. So in the upward direction, the forces the table pushes upward on the book. So sometimes it is referred to as the reaction force, which is acting upwards, and downwards is the weight of the object, which is the gravity, and these two are equal. Now unbalanced force. This situation of an unbalance is depicted very beautifully in this picture with the help of the number of people pulling the rope. On one side you are having one person, and the other side you are having two person. So obviously, going by the number of people trying to pull the rope in their own respective directions, we can clearly understand the effort applied by two people will be more. So the force will be unbalanced. So forces acting on an object to cause a change in motion. Whenever there is an unbalance, whenever the net force is not equal to 0, like in the previous case, the net force was equal to 0. So now if the net force net force is not equal to 0, then the forces are said to be unbalanced. So unbalanced force in this case is acting on this rope in one direction. If I consider that equal forces are being applied, so in one direction if one person is applying force F, in the other direction each one of them are applying forces F, so in one direction the force becomes 2F, isn't it? Because there are two people, so the total force is 2F on one direction and the other direction is F, so there is an unbalance. And obviously this unbalance will result in change in the state of the object. It will cause a change in motion. So an unbalanced force is one in which the net force is greater than 0. That's exactly what I was saying. So do you think there will be any motion? Yes. As you can see in the example again, in the picture, how the people are applying some force on one direction, the force applied is 25 Newton. Now if you remember, in class 8 you were taught that the standard unit of force is named after the great scientist Sir Isaac Newton. So the unit for force is Newton. Now this is something, the unit of force, that will be discussed in the later part of the lesson. So for the time being you can just consider the example. So on one side the force applied is 25 Newton and on the other side the force applied is 40 Newton. So the force produced by the blue team is greater than that of the purple team. So the net force is 15 Newton. On one direction it is 40 and on the other direction it is 25, and obviously the forces are acting on opposite directions, so one direction should be positive and the other direction should be negative, so the net force is 15 Newton. So that would tip the rope direction to the right. So obviously the net force should be acting in which direction? Obviously in the direction of the greater force, so the blue team. Similarly, the other example, the air resistance will negate 2 Newton of gravitational force, which will leave 48 Newton of net force pushing the skydivers to the ground. You can see that in the downward direction the weight is acting 50 Newton, while in the upward direction the air resistance is 2 Newton. So downward direction 50, upward direction 2. So 50 minus 2, the net force on the divers will be how much? 48 Newton. So this is a very good example of an unbalanced force. So now, can you tell me which one is the balanced force and which one is the unbalanced force? Example of which one is the balanced force and unbalanced force? In the first case, each team is applying a force of 300 Newton. In the second case, one team is applying a force of 400 Newton while the other team is applying a force of 300 Newton. So obviously the first case would be that of a balanced force because the forces are equal. Well, in the second case, the forces are unbalanced because the forces are not equal, the forces acting on the rope. So how to find out the net force? In the first case you can see 300 minus 300 is how much? 0 Newton. It is 0 Newton. That is the net force, and net force is 0, so forces are balanced and hence no team is going to win. But in the second case, since the forces are unbalanced, so 400 minus 300, that gives you an answer of how much? 100 Newton. So the net force is not equal to 0, so hence the forces are unbalanced, and obviously in the direction of the greater force the net force should be acting, and accordingly the team should move. As you can see from the picture itself that the other team has been able to pull the loser team towards its side. So whenever you are asked to find out the net force, you should always first of all try to find out the directions, how many forces are acting and in which direction. You should consider one direction as positive, the other direction as negative, then add the forces together keeping in mind the directions. and accordingly you can get the net force, or sometimes what is referred to as the resultant force. So if the net force is equal to 0, then the forces are balanced, and if the net force is not equal to 0, the forces are unbalanced. Balanced forces can never change the state of an object, but they can change the shape or size. Unbalanced force can produce any type of effect on an object. Remember, forces may produce a change in state, shape, size, speed, direction of an object. It is not necessary that they will always produce a change. They always tend to produce a change in the state, speed, direction, shape and size of an object. In the next classes, we will study about Newton's laws of motion. One by one, we will be studying about the different laws that will give us a better understanding about force. Thank you.